Hi there. Today we're gonna go over some items in chapter 7 to be ready for the test. So let's start now. Graph each function. This is no calculator. So how do we do this again? Again, the parent function for this we know is y is equal to 2 to the x. And if we make a table right here, refresh our memory, every time we use a parent function, let's try to use -2, -1, 0, 1, 2. You plug in the -2 right here, will give us 1/4. You plug in -1 here, will give us 1/2. 0 will give me 1. Even 1 here is going to be 2, and this will be 4. You plug in the points. -2, 1/4 is approximately here. 1/2, 1, 1, 2, and 2, 4. That's the graph. If we connect them all, that would be the graph of the parent function. Although the question is not that one. There are transformation involved here. There's an x plus 2 as the exponent of the 2 here. So that means the transformation here will go left by 2. Will shift left 2. So all these points will go to left 2. And there's a plus 2 here, which means you're going to go up by 2. So left 2, up 2 will be our transformation. So let's move them all. Left 2, up 2, left 2, up 2, left 2, up 2, left, up 2, left, up 2. Okay, so those orange points will be the graph of our problem here. And we know this will be a smooth curve going up. It's exponential growth because it's big. The 2 there is greater than 1. And we know that this is your horizontal asymptote, which is y is equal to 2. A good technique there, y equals 2, that represent the 2 on that transformation, on that equation. The domain here is all real numbers. The range here is y is greater than 2, or we write it better as 2, comma, going to positive infinity. Did I miss anything? I think that's it. Next. Here it's going to be 1/3. Let me do this one again. So the parent function here, y is equal to 1/3 to the x, wherein x, y, -2, -1, 0, 1, 2. Again, we still use these numbers for our parent function. -2, you plug it there, it's going to give you a 9. -1 will move a 3 up. 1, 1/3, and 1/9. So if we plot the points here, -2 to the 9 is somewhere right here. We know it's exponential decay because 1/3 is between 0 to 1. -1, 3, 0, 1, 1 and 1/3, and 2 and 1, and a very small number. If you see those 5 purple points, that's the graph. Those are the points to graph my parent function. Although there's a transformation in this problem, x minus 1 tells us to go. Transformation will go to the right 1, or translate 1 to right. And then there's a -2 here that tells us to go down by 2. So here, so we go right 1. Let's go here first. Right 1, down 2, right 1, down 2. So that pink point there. Right 1, down 2. There. And this will be pattern 2 like that. Okay, if we connect them all, the graph will be a smooth curve like that. Don't forget the arrows. And then this is your horizontal asymptote, which is y is equal to -2, which again, I said that's -2 there. And the domain here is all real numbers. The range goes by from -2 to positive infinity. Get it? We'll skip that one. Okay, here. How do we solve this one here? 36 and 6, do they have the same base? Our goal is to keep their base the same. 36 is 6 squared. Do you agree with me? But there's a 3x there, so put the 3x with that. 6 cubed. They have the same base here, so you can cross that out now. 2 times 3 is 6x is equal to 3, so therefore x equal to 1/2. Again, take note, this is a no calculator portion on your test. 2 to the negative x, I know the 32 is same thing as 2 to the fifth power. And this 2 to the negative x, because 2 times 2 times 2 times 2 times 2 is going to give us 32. So they have the same base now, so negative x equal to 5, so therefore x equals negative 5. Okay, let's go over here. Let's do number 8. You would like to make their base the same, so I'm going to move the 36 up. So this will just copy 6, negative 2n. If I move the 36 up, we know first that 36 is 6 squared. So I can move up the 6 squared. If I move their position going up or going down, the exponent change. So this will be now 6 to the negative 2 for the 36 here if I move it up. But there is an expression here, 4 minus 2n. So now they have the same base. I can cross this out. That leaves me negative 2n equals, distribute this, negative 8 plus 4n. Then the rest is just algebra, solving an equation. I'm going to move this one to the other side, negative 6n equals negative 8. Divide everything by n. That gives me negative 8 over negative 6, or positive 8 over 6, or positive 4 over 3. Something challenging. This one here, maybe. 4 does not go with 8. You should know that. But you know that 4 goes with 2 squared. So I can drop the 3x minus 2 here. Likewise, you know that 8 goes with 2. 2 to the third power is 8. 2 times 2 times 2 is 8. And then put the x plus 1. Now they have the same base. And I believe you know the answer from here. You know how you can work from here. Cancel this out. Distribute, 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 distribute. 6x minus 4 is equal to 3x plus 3. Solve that. The 3x equal to 7. So x equal to 7/3. Find the missing term in the arithmetic sequence. This is arithmetic. Why we're having this one here? But anyway, how do you find the arithmetic sequence? We find the arithmetic sequence. Well, we're not doing arithmetic sequence, so I'm gonna cross this out for now. Determine whether the sequence is geometric or not. This is what we're doing, geometric, not arithmetic. Geometric is something when you multiply each term to get the next term. Arithmetic is something you have to add or subtract to get the next term. So here I see 198, 1985. What you need to do, you need to divide this by the previous one. Divide this by the previous one. Divide this by the previous one. If the quotient will be the same, so therefore that's a geometric sequence. So 1985 divided by 198, I get 10 point something. So what I'm going to do, I'm going to divide 19855 divided by 1985 alone. It gives me 10.002. There's a slight difference, and any small difference, it has to be perfectly the same. Since they're not common, the ratio is not common, so I know number 1 is not geometric. Number 2, divide negative 12 by negative 4 will give me a positive 3. Negative 36 divided by negative 12, I know it's going to give me 3. Negative 108 divided by negative 36 is going to give me a 3. So there is common ratio, so I know this is a yes. How do you do the fraction? 4/5 divided by 2/3. Again, on this section, you're allowed to use calculator. I can divide 4/5. 4 divided by 5. Enter. Divide by parenthesis. 2 divided by 3. Close parenthesis. Enter. The answer is 1.2. Let's see the next one. 6 divided by 7. Enter. Divide by parenthesis. 4 divided by 5. Close. It's 1.07. It's not. So this one here is not. Okay. Now use the given terms and the common ratio. Find the specific one. Okay. We'll continue this one on the next video.